Yeah, hi, good evening, everyone. So today we will discuss the week 6 and week 7 live coding problem. So both problem we are combining today. And okay, so we release the problems on the Replit. A second. Meanwhile, you can open the Replit and you can refresh the page. And you can see the week 6 and week 7 problems. So we have total three problems in the week 6 and three problems in the week 7. Total 6 problems. Okay, problems are not too much difficult, so we can cover these problems in the today's session. So very small logic problems are there. Okay, so first thing, open the Replit team. So I checked that only one is joined on the Replit team. Please, other also, can you join the Replit team? Okay, if any of you have not joined the Replit team till now, so you can join the Replit team through this link I have sent in the chat box. You can click on this and you can join the team. Then you can see the problems and you can start solving these problems. If you have already joined before, then you can open the Replit team and refresh the page, and you can see the both weeks, week 6 and week 7. Okay, so we will discuss the problem one first. Week 6 problem 1. Okay, so in week 6 we have learned this max heap topic. So you know that what is the property of the heap and what is max heap, what is min heap. So based on that, this is the one question, and question is very simple. Okay. Write a function type of heap that accept a heap A and return string max if input heap is max heap, min if input heap is min heap, and none otherwise. Okay, so one basically one input list is given. Okay, so here we are saying that this is one heap. Okay, now we are checking that this heap is a max heap, min heap, or nothing. Okay, none. That means it is following the max heap property, it is following min heap property, or it is not following any property. So based on that, we will return the answer for this. If you remember that in week 6, in graded assignment or practice assignment, maybe some questions are also there related to this, where one heap is given and asking that what type of heap is. So same things. Now this time we are doing this thing, things by
But
the port.
we can use anything, right, for to solve this question.
Yes, yes, you can use anything. Okay. So just check the property. This heap is following the max heap property or min heap property or nothing. So based on that, return the answer.
Sir, Replit is not loading for me.
Okay. So just wait for maybe some few minutes, 2 3 minutes. I think it will load it. So what message is coming on your screen?
Showing loading.
Loading. Okay. So maybe it will take few minutes to refresh some settings. Just wait for 2 3 minutes, then it will load. Okay.
Okay, sir.
Okay. So this topic is also important with respect to the exam, which exam. Okay, so you should know what is the property of max heap, how we can identify that the what type of heap is. Okay, and some related question is also asked in the previous terms based on this max heap or min heaps. So how we generally insert the element and what time complexity is required for insert and for delete. If any index, you know the index of any element, what is the time required to update the value of that element. So some different types of questions will be asked on this max heap or min heap question. Okay, so you should know very well what is the type of this data structure and how we can, what is the property, how we can identify this. So can anyone tell me what logic you are thinking?
So basically, first we kind of find the length of the array, right?
Okay.
Then we kind of create two variables like a is minute is maxip, like we initialize to true, and we'll
Mm-hmm.
find any counter example, right? So we'll run the loop. The one other trick we can do is we run the loop from left to middle, because we know that after the middle it's all leaf nodes. No need to check,
Yes,
right?
correct.
So because we have to check the property for heap property,
Hmm.
the parent node should be either higher or lower than its left child or right child, which is 2i plus 1 and 2i plus 2, right? So I
Yes,
don't
yes.
need to run the loop till n. In fact, it will create index out of bound and all that. So if we do that, then I think if I find any evidence against while I'm checking, if it is greater than, then my one of the property will be false. But once I go through it, I think if it is a maxif, the initialization will not be there.
Yeah.
And the end, if it is both no, then I return none. Otherwise, one of them will be true. So that's the kind of the logic I'm
Yes,
thinking.
yes. Correct, correct. So that is the correct logic. Yeah, so you can start from the first parent node from the bottom part and to the root node, and simply check the property between parent and childs. If parent is greater than the both child, then just make this flex, you can say. Simply check the relationship between parents and childs. Based on that, you can identify that the heap is max heap or min heap. Anytime if one condition, suppose parent is greater than childs, both childs. Okay, so you can uh, definitely you can make the min heap property as a false. That is not possible. Yeah, correct. Yeah, so just convert this logic into the code and check. I hope this logic is clear to others also if someone is not able to understand.
Sir, can you explain it once again?
Okay, one second.
Like only the first element I'm checking if the second element is less or not, or if
One
it
sec.
is.
Yeah, 1 second. So
But then that none condition would, how would we check that?
okay. So
Maybe
suppose I'm creating one random heap. Okay. So like this, 1, 2, 3, 4, 5, 6 random. Okay. So see the sequence. So I'm just getting this input for my question. So if I create the heap diagram for this, okay, so heap logical heap. So this will look like this. So one, okay, and two, three, four, five, and six, and seven. Okay, so you can simply identify. So what is the length of this list? So that is the actually size of heap. So we can see that total elements are seven. So we can simply 1, 2, 3, 4, 5, 7. Okay, and if we remark the index, so 0, 1, 2, 3, 4, 5, 6. Okay, so what is the first parent actually? If we remove all the leaf, okay, so these are all leaf, we can start from this parent. So this is the first parent which have actually childs. Okay, otherwise lower all nodes have leaf node. These nodes are actually not contain any child node. So we can start checking from this node which have some child node, and we will start checking the relation between parent and child nodes. Initially what we can do, we can simply set like one two variable like is max. Okay, and we can set this as a true. Okay, and another variable is min equal to true. Initially we are set assigned this variable for the both. After that we will simply check the relation between parents. So 3, 6, 7, and we are checking first thing is if parent is greater than the sorry parent is smaller than the child nodes. Yes, true. Okay, if this condition is true, definitely we will mark this max as a false. Okay, if in our heap node if we are checking any one parent child's relations, so in actually min heap parent should always be smaller than the child. In max heap parent should always be greater than the child's. So if this in the first checking, if we are finding out that this parent node is smaller than their child node, so that means this part is satisfying the min heap property. Okay, so if this part is satisfying the min heap, definitely the whole heap will not be a max heap. Okay, so we can directly set this is max equal to false. Okay, now we will check the next. We will reduce our value. Okay, so this is the index 2. Then we will move to the index 1. Okay, so now we will check the relation between this subtree 2, 4, 5. Okay, this is also satisfying the min heap property. Okay, so this is fine. We will move to the next process. Now we will check the next parent. Okay, so 1, 2, 3. So this 1, 2, 3. Now same things, 1 2 3, this is also satisfying the min heap property. Parent is smaller than the child node. Yes, once again we will escape. So final, after completion of this process, you can see this is max is become false. Okay, now this is min is actually a true. If you are getting any one true after completion of the process, you can return the answer, this is a min heap. Okay, if both variable are moved to the false condition, so suppose the first part is representing a min heap, we are setting max is max equal to false. Next part maybe contain the condition of max heap. Okay, so suppose like if we replace it 2 4 5 like a 6 and 4 and 5 like this. Okay, so when we check this subtree, and you can see this is satisfying the property of max heap. So at this time, if this is satisfying the max heap property, definitely our heap will not be a min heap. So we will set this as a false. Okay, so after completion of the process, if both variables are false, okay, then we will return the none answer. That means our heap is not satisfying any these two conditions. So is max heap is also not satisfying property, and min heap also not satisfying property. Then we will return the none answer.
So, but like when we'll be going through the different parents,
Hmm.
it may happen that 3 is satisfying max heap
Huh.
and 2 is not satisfying. Or,
Huh, so definitely it is a none condition.
but like because we set max heap and sorry is max and is min to false initially or true.
Initially true.
Okay.
Okay.
So each time, so if we get max heap to be true, max so this min condition will become false.
Yes, correct. Opposite condition will become false if we find any type of property.
Hmm.
Okay, if we finding the both condition, both type of subtree. Okay, so min heap or max heap. So we will
Okay,
make both as a false.
okay. Because we are not setting anything to be true, nothing will
Hmm.
get cancelled out, and
Yes.
it should work. Okay.
Okay, so you can follow this logic in your code and just make change in the variables. So in general, some error actually we when we write the code, we generally get some errors. So what is the common error actually? So at the calculation of this parent and child index, okay, so this is actually a list. So we can identify the child node using this index. Okay, so as we said that we will start from the first parent which have actually child. So how we can identify this first parent, and what will be the left child and what will be the right child in this list, how we can identify this. Okay, so simply left child and right child information we can identify by like this formula. Suppose I am calculating the left child of this 2 node, okay, in the tree. So what is the index of this 1? So I equal to 1, and we want to find out the what is the left child of this I and what is the right child of I. So simply we can identify using left equal to 2I plus 1. Okay, so this is the left child, and R equal to 2I plus 2. Okay, so you can see in the diagram, so we are getting one value, and 1 into 2 plus 1 3, and we are getting 3 index. Okay, and 2 into 1 plus 2 4, we are getting 4 index for the right child. So what error actually comes when we start from this 3? Okay, Suppose this child is not there, we have only 6 element, still this will be the first parent to the check. Okay, so we will start from the last parent, 3 to 1. Suppose this 7 node is not there. Okay, so at the time of checking, we are calculating the what is the left child index. So this is 2i plus 1. What is the right child index? So we will calculate this 2i plus 2. So at the time when you are calculating this left and right, so also mention one condition: this r value should be smaller than this total size. Okay, size of the heap. And what is the last index actually? If this value is coming less than or equal to last index, then you will check. Otherwise, no need to check. So suppose the size of this heap is 6, and you calculate, so the index of this 3 node is 2. Okay, and you calculate this r value, 2 into 2 plus 2, you are getting 6 index. But 6 index is not there. Suppose this 7 element is not there in the heap. So at the time, just check that this what value we are getting for the right child index. So this 6 value we are getting, but what is the size? What is the last index of our heap is? Total size is 6. So last index will be 5. So now we are getting this 6 value greater than 5. Okay, so this is not possible. So in that case, do not consider to right child for the comparison. Okay, otherwise you will get the index error in some test case.
Sir, I am not able to pass one case.
Okay, so maybe this error will be is coming. Okay, let me open your tablet. Siddharth.
Is it third test?
No, third test, yes.
Answer is none. I am also not able to pass that test.
J equal to, I think here 0 it will be. J will be 0. In third test, J will be.
Okay, so this one, let me discuss this example on the notepad. So here we have this heap 1 5. So 1 and 5, 4, 7, 6, 3, and 2. So you can visually see that so this part is actually maintaining the max heap property. Okay, and this part is maintaining the min heap property. Definitely answer should be none. Okay, so answer is correct. So why your code is returning error for this? So some logic is not correct, that means.
So that range n by 2 minus 1 would not check the middle element, right? The root node.
N is the size. Okay, total we have 6 element.
So if you have got an odd size, let's say 7 or whatever, I don't know. In this case, we have
7. Okay, and okay, we are calculating 7 by 3. Okay, we will get 3. 3 minus 1 is 2.
yeah.
Okay, and we are checking from 2. So 0 1 2, yeah, this is okay. Okay, we are getting 2. So here actually 2 will also not consider in this range.
Good.
Okay, so you will range will start from 0 and 1. That means last element is not
Correct. So
completing.
we just get rid of that -1, then it should work.
Okay, so this range should increase by 1. So what's formula actually we should take for the correct answer? So this is 7 size, and we should getting this as a 2 index for 7, and for 6 we are also getting 2. Okay, 6 7. So length of n. Okay. So just remove this -1 part, Siddharth. Now first condition is failed. Okay, let me check what is first case. 1 2 3 4 5 6 7 8. Okay, so 8 and 4. Okay, now the error is coming.
Index error, index error.
Yes, index error. Okay, so now we have eighth element, but that eighth element is a left child of the parent only. So there is no right child. So this will give a index error. So you have to validate this. If you are getting this 2i plus 1, which is greater than the size or last index, so just mention the condition first. If 2i less than equal to n. Other also.
In the other side also. uh, yeah.
So now first, okay, let me check. For I in range this, so the first condition we are taking is greater than 2i plus 1 and 2 into I plus 2 is greater than equal to n less than equal to n. This is okay. Equal to n. Okay. What error is coming now?
Uh, it should be mean, but it is none.
So none we are getting 1, 2, 3, 4, 8, 5, 6, 8, 7. So this is min heap property. Let me check. 1, 2, 3, 4, 8, 5, 6, 7. Yeah, this is min heap. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is comparing. So if this condition total size is 8, 1, 2, 3, 4, 5, 6, 7, 8. So 8 we are getting 4, 4 minus 1, 3. Okay, 0, 1, 2, 3. Okay, fine. So we are checking from root to node side, last node side. Okay, 0 to. Okay. 0. It's okay. And this condition is true. That means a is greater than and a is greater than both child. J equal to 1.
Now it is passed, sir. I got it. I changed this elif, this return. I got all the cases passed.
Mm-hmm. So
I
what change you have done?
this return none condition is there na, in line number 17, 18.
Okay, 18.
So I changed the elif to this because see if this I mean 2 into I plus 2 is
Mm-hmm.
greater is I mean if it goes higher than n, then it will return none. But we don't want that.
Okay, okay, okay. Is this condition?
That condition here earlier in 17 I was giving only else, uh, else return none. So now I have entered 2 into I plus 2 less than n, then return none.
Okay, okay.
Otherwise, it should not return none because we already traversed the list. So it should
Mm-hmm.
return either max or mean, whatever
Okay, okay,
value
fine.
of k it is.
Okay. Yeah, passed. Okay, max. Okay, so you are only managing one variable j to identify this. No? So j, if
Yes.
j equal to 1, then max,
Uh,
otherwise min. Or in between, you are getting the none answer. At- Okay, so if you are
So
getting,
earlier, if it was 2 and then it becomes 1, then it should return none. Earlier, if it was 2 and now it is becoming 1, then it should return none, right? Because earlier,
okay, okay.
or if one element is higher and one element is lower, then also it should return none. So that is taken care of by the 17th.
Mm-hmm. Okay, okay. Fine. Yeah, correct.
So if I would have got time to think, then maybe I would have given a different code. But this is the code.
Yes. Yeah, so some this part is actually create confusion. So this extra part we are using only one variable. Otherwise, you can use two variable, and based
Yes.
on that you can easily return. So there is no need to maintain all this none part here. Okay. So finally, after that, in the later part, you can directly return the answer based on this two variable conditions. Okay. So this is working. Then this is also correct. Fine.
Sir, why don't you release the problems a little bit earlier so we get some time to think about it?
Okay. So sometimes it may be a chance nobody will join the session actually.
Okay.
Okay. So suppose if you have done the problems earlier, so there's no need to join. Okay. So any other have done this problem?
Yes, sir. Solved it. First one.
Okay. So second problem is basically depends on this Kruskal algorithm. So you can skip that problem, big 6 second problem for the later part, but you can move to the third problem.
Basically,
Okay.
it's find you in the Kruskal you find the MST, but here you return the edges which are not MST basically, right? It's a
Yes, yes,
inverse.
yes. So this is simple Kruskal algorithm based problem. You can use that algorithm. You can return the answer. So it will take some time, but algorithm knowledge is requirement here. So you can move to the question number 3. So some log that is actually logical question. So 2 have submitted. Okay, let me check the another solution.
Typos are so that should be LST. I made a mistake.
Where?
The length actually. So initially I tried A, then I changed it to LST. So modify it.
Okay, this one. So you have updated.
Updating it now, sir.
Oh, on my screen is not. Okay, so this is directly reading the A from the input.
Yeah, because that was LST actually.
No,
Yeah,
okay,
so I
that's
just now I use, let me do some. It
okay.
should be fixed. Yeah.
Yeah, so this is the logic which we have just discussed. We are taking two variables, and then we are reading the parent node from the last to the root node, and here you are calculating the child
Are we doing the
index.
first one only, right?
Yes, first one. And after that you are okay. So this left child property, if it is less
So
than,
this is
so
just to
this
prevent that out of that is so basically I coded it this way so that way will ensure that I don't get into that array index for the bounds error problem.
but I think this condition will never, the opposite condition will never be satisfied. Okay. uh, okay, so this part is okay. Yes, correct. False, false. Yeah.
We have to try the third problem.
Yes, yes, you can move to the third problem. Second problem is directly based on the Kruskal algorithm. You can write the Kruskal code and just return the edge. Actually, which we can remove. Okay, but third one is actually a little bit logical.
So we have to define
My
the union class also we have to define it. That.
So union. One second. Let me
I
open
mean,
the
union
problem.
find class where we have the initialized all the parent and random and then find an union function also we have to define before we do the Kruskal.
Let me open. So the some part is given in the code. One second.
We practice. So I use the class definition, union find class.
Okay. Huh. So union find this data structure you can use, which is defined in the Kruskal algorithms. So beak 6 is also once again there. This part is discussed in detail to improve the complexity. Otherwise, you can directly use the beak 5 Kruskal algorithm, which is actually not efficient, same as a beak 6 algorithm. But here you can use any. Okay,
So
so
best way to do is to define the class union find, initialize, and the find and union function. So that's the then Kruskal becomes easy, right? Because you just
yes, yes,
create a new instance of union find and then run the loop for the edges and find the MST basically, right? And
yes,
keep
yes.
adding So MST is complete, then you search through the list which is not in the MST.
Mhm. So at the
That's
time of edge insertion in the Kruskal algorithm, if any edge is not the part of the Kruskal, you can just receive the edge in the answer list that we
yeah,
can remove. So if
yeah.
any
So,
edge is creating the cycle, basically,
correct.
so you can just keep as a answer list.
We were right about maintaining two variables. It is way easier for the question one.
Yeah. So come to the problem number three, B6 binary search tree. Okay. Okay, so write a function k, find kth largest root, comma k. Okay, here binary search tree is given. Okay, and the root reference is given for the binary search tree, and BST have n elements, uh, and an integer k. Okay, so k value is given in the input, and k will be greater than 0 and less than equal to n. The function should return the kth largest element without doing any modification of binary search tree. The complexity of the solution should be in order of log n plus k.
So that means so we have to find the k means we have to take log k steps to go there.
No,
And
not log k. Actually, k means kth largest element. So if we say that k equal to 1, that means we are asking the largest element in the binary search tree.
Sir,
right.
suppose we go to the minimum element, we go find minimum element in the we find the minimum element in the tree, and
Binary
then
search tree.
uh, minimum
Okay.
element in the binary search tree,
Uh,
and then we go ahead, we traverse the tree, uh, but traversal is a recursive procedure.
same approach actually we have to use here. We have to also use the recursive approach, and but the complexity should be log n plus k. Otherwise, you can find the solution using, you can simply apply the in order traversal, and you can get the sequence in the increasing order, and you can return the answer from the last. What is the k value based on this?
But
Okay, but that is actually n.
that order will not be log n plus k, no?
No, if we are applying the in order traversal, so in order traversal actually will run on the each elements. Okay, so that will traverse each element of the tree, and in that way the complexity will be n.
So for log n, what we should to do? We have to find the minimum element and then
This is the complexity to find the kth largest element. So this is the maximum complexity. Log n means height. Actually, you can see that.
yes,
Okay, and k means you can use the k extra steps in the addition of height.
yes, yes, yes.
So that means you're saying we basically use a stack to do the in-order traversal, rather reverse. Then we kind of start from the root, go all the way to the end.
Hmm.
When we kind of basically that proves that we got the largest value. Then we kind of backtrack until we kind of
Okay, so
add
I'm
on.
just giving some idea of the on the diagram. Okay, suppose we have one binary search tree. So I'm creating the binary search tree 7, 3, 1, 5, 15, and 12. So it's like 13. 25. Okay, so suppose this is a binary search tree in the input, and this first node is a root. Okay, and we are asking what is the k equal to 1. Okay, so what is the first largest? So first largest we can directly find.
minimum.
No, largest.
Okay, okay.
Largest means maximum.
Kth, kth largest means first highest
So maximum.
Yes,
maximum.
maximum. Okay, so first highest means first highest we can directly find. We can simply traverse in this path. Okay, and the node which have the last right node, rightmost, we can say that. So that is actually a first highest, the first largest. Okay, so 30 is the answer for this. If we suppose ask for k equal to 2, then you need to return the second.
Sir,
So the
what if
answer should be 25.
we just found out the level, and
Hmm.
then for example we have three levels here,
Okay.
right? We know that the last element of this level, if it is not the left one, it is going
No,
to.
here you can see we have 4 level.
Hmm.
Okay, and last level contain only this 25. But we cannot say that this 25 is largest.
It is not of the form 2i plus 2, right?
No, no. So binary search can make any form, binary search tree. So we can insert based on the insertion. So it may be in any form.
and
This is
and,
not
and
this is not
also
a binary heap.
correct, and it may be incomplete also,
So we have
right?
to delete the max sequentially.
Sequentially means
You delete the max k times.
uh-huh.
That will give you the kth maximum.
Okay.
But you have to
Okay.
reconstruct. But you have to reconstruct the BST. Will that be what will be the order to reconstruct
No, no.
after?
So delete operation actually will take login time,
Mm,
and if you want to perform a k deletion. So every time login complexity will be there, so it will become like k login.
K log n, yeah. K is a constant or finite.
Kj this value, what is the possible value for first largest, second largest? So k will always be the equal to the n, maximum n.
But I think you wanted log n plus K, not K
Log
log
n
n.
plus k.
So this I know in time complexity K is like a constant, right? K is a finite. Anything that is finite can be considered a
K
constant.
range is like 0 to n, like this range.
Right. So, so yeah, so K is definitely
So we take log n steps to reach the maximum. We take
Hmm.
log n steps to reach the maximum, and
Yes.
then we put them in a loop. We delete the maximum. We delete the maximum k times.
Sir, what if we looked at 2k minus 1 plus 2th element, if there is whatever is the last such occurrence?
Sorry, 2k minus.
2k minus 1 plus 2, so what would be 2k,
What is
2
this?
2k then?
Oh, here actually, why you are using this 2k, 2 into k minus 1 like this?
See, even if it's incomplete, it is still following the general pattern, right?
Yes, yes. So this is not a min heap or max heap pattern. So we cannot apply this left child or right child formula here directly.
And we cannot modify the binary tree also. We cannot delete, right?
Hmm. Yeah, this is also given in the question. So traversing operation you can use. Okay. So in that way we can find out the first largest.
Yes,
Correct?
yes, yes.
Okay. So this is the only login process. Just move to the rightmost child, and we know that this is the first largest. After that, we can simply traverse using a recursive algorithm based on the left child traverse or like this, and we can use one counter for this. So this is the first. We can use one k counter, and when we are reaching at the largest element, we can set it a k equal to 1. Okay. Now we can use like in order traversal type from here.
From the largest element.
Yes.
Okay.
Okay. So at the time you can simply traverse like so here k equal to 1, then you can apply the left child. Okay, so what is the left child of this? And at the time of left child traversal, just apply the in order traversal. Okay, so left, one second, not in order. Suppose this is given like 20 and 28. So second largest will become this one, 30, then 28. Not traversal. Okay. Post. So you can apply some traversing technique from the largest elements. Simply, if this largest element have left child, okay, so you will move to the left child. Okay, and suppose after reaching at the left child node, if this left child have the right child, then you will move to the right child in that way. Okay, so at any time you are reaching at the right child, so which actually not have any left or right, so that at that time you will increase the counter. Okay, so here you are, when you are reaching here, so there is no left or no right. Okay, so you will increase k equal to 2 like this. So this is the second largest. And when you revert back using the recursive approach, so after reaching at the last node, so there is no node available after that, then you will revert back, and at the 25 you are coming. So you can increment the counter again like this, k equal to 3. Okay, so in that way you need to traverse, and you can also use one counter. Okay, at any time, suppose if we are asking that what is the k equal to 4, fourth largest, so at the time of traversing, when you are getting k equal to 4, okay, when you are increasing this counter every time, and at any time when you are getting this k equal to 4, at that time you can stop the process. Okay, when you are reaching like this k equal to 4, and you can stop the recursive call process at this 20. So this is look like you are reading the height for the first height for the largest element. After that you are simply traversing k element. Okay, and at any time you are getting the kth element, you are stopping the process. So the code should traverse look like this. So
Okay,
just
so
think in that way.
we'll be doing in order travel, sir.
In order traversal, but in order traversal actually, okay, so that is left, print r. So after reaching here, you will move left. Okay, then left. No, not in order traversal actually.
So we'll do some traversal and we'll maintain a counter. So
Hmm.
maybe
So what we can do, we can create a recursive call which we are applying from the root. Okay, so we are applying from the roots. What type of algorithm we will apply from the root? We will simply check if the 7 is containing a right side node. Okay, because we are first goal is to find out the largest element. Okay, so in that way we are checking that what is the, if this node have right side node, then we will move to the right side.
okay. So
Otherwise,
if
if this node doesn't have the right side node, then we will apply the this the same algorithm on the left child node.
But sir, why?
So suppose we have binary search like this: 7, 3, 5, 1, like this. Okay, there is no right child here this time.
Okay, kth largest. Fine.
Okay, and we are asking what is the second largest. So second largest will be 5.
Yes.
Okay, so at this time we will apply the first. We will find out the first largest. So this will become a first largest. So we will set our k equal to 1. Now we will check that there is no right child. We will apply the same algorithm on this node, this part. Okay, from this node. Now we will check what is the rightmost part of this. So when we are finding out the rightmost node here, so this is 5. At that time we will increase our counter k equal to k plus 2 plus 2. Okay, and anytime we are when we are reaching at the required kth value. Okay, so we will take one another value. So suppose k equal to 2, we will use some counter like c equal to 1. Okay, so c equal to 1 at any time when we are getting c equal to 2. So now c is 2, c equal to k. Now we will stop the recursive call process.
Okay.
Okay, so this type of approach you can use. Just create a recursive function from the root node and just check that if this node contains the right child or not. Okay, if this contains the right child, just move to the right child and apply the same algorithm on the right child. Okay, if the next node also contain the same right child, then move to the right child again. Okay, at any time when we are getting no right child value, so at that time you can set the counter or you can increment your counter. So initially you can start c equal to 0, and when you are reaching at the node which have actually no right child, so you can increase your counter c equal to c plus 1, like this. Okay, and once again, so this is the last right child. Then you will check that is there any left child or not. If there is a left child, then apply the same algorithm on the left child. So this algorithm will once again check the right part, and same things. Just use this counter and increment the counter when you are getting the rightmost child every time. Okay. So at any time when you are this counter is reaching to the k, so just stop the process. Return the answer. So anyone is trying to solve this using this logic?
Sir, I'm trying, but I'm not very sure. We'll see if that happens.
Okay, no problem. Okay, so I am also writing the solution code for this. Okay, so first we will create a main function which we need to create. So find kth largest and root, comma k. And in this function, actually, we need to create one recursive function. So here parameter is already given. So we will create a separate function for the recursive approach, and we will call that function from here first time. Okay. So suppose I am writing another function like def kth element. Okay, and we are passing a root node, or we can give any value like here. So root, I am mentioning that. So we call this function from here. So kth element. Okay, and initially we will pass the root. Now we have to take some. We have to use some counter, global counter. Okay, so here we will use some global counter because we are using recursive approach. So we will use that global counter inside the recursive approach. So I'm just defining one global counter like this: count equal to 0. And okay, so to store the final result value, element value, we will use one variable like result, and initially we are setting -1. Okay, this is the initialization. Count equal to 0. Okay, so this is the function, and now return the result. So this is the main function, and now we have called this function above function from the main function. Now we will write the definition, recursive definition from here. Okay. So first we will define the global counter to use. Global count and result. And after that we will check the condition. If root dot right, okay, does not equal to none. Now we will call the same function, lower one function. Okay, so it's just what is the things is select the right information. Kth element root dot right. Okay. Okay, so this is the recursive call. So at any time when we are reaching the rightmost child, okay, so this is the recursive. So in that way, we will move to the rightmost child, and we will increment our counter here. Count count equal to count plus 1. This is the first time. Now, at the time of incrementation, we will also check our condition if our count is equal to k. Okay, so k value. K value is not given. So I think okay. Here. So we will set our result equal to what is the value actually. Okay, so root dot value. What is the current node value? So root dot value will set, and we will also return from here. Otherwise, so this is the case when we are reaching at the rightmost child. So this is the first condition. if root dot right does not equal to none. Okay, and after returning the answer, if this k count is does not equal to k, so in that case we will simply call the same algorithm on the left child. This time left.
So essentially, it is a RLN that traversal, right?
Yes,
Post,
R
post order. I think post order we
post
discussed.
order is different actually. When we traverse left first, then right, then print. But here actually we are traversing right first.
Hmm.
As like reverse of in order.
Yeah, reverse. This is actually reverse in order, right?
Yes, yes.
Oh
Correct.
my God.
Okay, so yeah, this is the part. Okay, let me test the test case. Test. Oh, past, yeah. So this is the simple, very small code actually, but little bit tricky. Okay, so are you getting the logic? What we are using here? So every time we are traversing the rightmost child, okay, and when we are reaching the rightmost child, we are increment our counter. Okay, and now we are checking our count is reaching count is equal to k or not. If count equal to k, then we are storing our result equal to root dot value, and we are returning from here. Otherwise, this value is not equal to k, then we are calling the same function on the left node. Okay, then same things we are calling from the left child, then same things we will identify the rightmost from the left, that will become a next largest.
Sir, what if we are starting in the beginning
Hmm.
and we are getting that the root dot right is equal to none?
Hmm.
Then we will not execute anything. Recursive call will also not happen. But left it there may be something.
Okay, well, let me check this. Global counter agent root dot right is not equal to none. Yeah, okay.
Right, because we'll be going kth element to root dot right. So we are checking right element. Right, and if there is a if right element we find something we are returning. Then we are doing that on left element, and then this will obviously check for right. But in case that thing does not happen, then we'll not be checking left. That is case which you discussed.
Okay. So in that case, I think if the first condition is not true,
Hmm.
then right is not equal to none. Okay, what we will do?
So maybe we have a else condition which does this.
Yeah, we have to use the else condition for this part. But what we need to do for the else case, because we have to set counter for the root node as a one first. Okay, correct this.
And maybe the same thing will continue.
Else part is not equal to none. Okay, we have to think here.
Haha, counter equal to ठीक है, counter equal to counter.
So the first condition is not true, so then we are not setting any counter as part. So we will set first counter, and we will use this. Right. Okay. Hmm. This part and then this part.
Hmm.
Okay.
Yes, this should work.
Because if this first condition is not true,
Hmm.
then we are moving to this part. None. No, it may create problems. Let me test the test case first. Oh, failed. Okay. So now,
Yeah.
actually, when we are reaching at the rightmost child, so rightmost child is the identification for this LF condition. I think we have to use some LF condition.
Hmm.
What should be the LF condition then? So this is the only one case. First, if root is actually first root is the single root and there is no right child.
Yes, that is. Maybe we can try running it without this and see how many cases we are passing, and then we'll just.
No, all test cases are pass. I think that type of test case is not configured. Okay,
Okay.
but that should also be the case actually. Suppose so here actually in the input first. Okay, so here we are giving one input for to create the VST, and what type of input we are giving? Okay, this.
Sir, and else if we can give two condition, no, like left is not none, then right is not none, and we can give the same statement, right?
Sorry, can you repeat?
Sir, in second part, like else part or else if part,
Hmm.
we can give like if root dot left is not none, right? If the
Ah,
first condition is not there, anyway, it will be like left is not none.
ah.
If it is none, we don't have to check, right? Then again, we can say if root is not none, we can give the same steps, right?
Yeah, like if root dot left is also not none, because if root dot left is none, we'll obviously not be doing anything.
Yes, anyway, if it is root dot left is not none, we will enter into it. And then we can give the same statements as above, right? If it's root dot right is not none, again we can give the same statements.
Okay, but actually, so in the first loop, suppose we have the right child. In that case, when we are reaching at the rightmost child, okay. So at that time, this else part will be actually run.
Like that, right?
Okay, and else part will be run, and so this is the case actually. Uh,
Okay.
if we are reaching at 30, okay, and then we are checking there is no right of the 30. So as we will run right, we will run this else part on the right child. Then we will reach at this 28. At that time, we will set our counter equal to 1. So this should not be the case.
Okay. So then maybe go back to the code.
Or we can set some specific condition only for the first time root node.
Yes, yes. Only somehow
So,
we identify that that is the root node.
and then
Or
we can separate the logic.
uh,
Rightmost, rightmost.
what if we checked it while we were calling before we called the function?
Hmm.
So we have root right in the find kth largest. If we just check that if that root dot Right
So
is not
inside
none.
this, okay, so you are saying that inside this we apply this while this
Yes,
right things, okay,
if
maximum element.
just to handle that that first condition, right?
Yes, yes.
Then the function will work as we expect it to, because everything only the first condition is first case we are having problem. Rest we do not have problem with this function,
Hmm.
right? So we handle it before we are calling it, and that should work, I guess. But then we do not have any test case here to test it. Maybe we can.
So you can simply check this with some test case. Okay, just create the test case according to that. Yeah, you are saying correctly here. So first we can apply the logic to find the maximum. Okay,
Hmm.
so definitely if we are applying the logic for to find the maximum, so we will reach the rightmost child. If rightmost is not there, so first this will called as a right maximum element in this. Okay, so we will use the while loop. Yeah, correct. And after reaching this first maximum value, then we can set k equal to 1 counter, and then we can apply this recursive call.
So why where did the while loop come in?
While loop we will apply for the main function.
Okay. I was thinking more in line with if root dot right is actually equal to none, then
No, but we are calling recursively the same function, so root we are actually changing.
because then the else condition would not be there in the kth element thing,
Hmm.
right? And if we just checked that if that root dot right is equal to none, right? We pass that root dot left, and root dot left is not equal to none. Then we pass root dot left when we are calling find kth largest,
Hmm.
right? Obviously, we'll have to increment the count by one while doing that change. Otherwise, we call it like we called it,
Hmm.
right?
So actually, this part we have to call after identifying the first largest.
After identifying the first largest.
Hmm. So first largest, this means maximum. Okay, if k equal to 1 like this, so we can use the that code to find the maximum element. So what we can write, while like this, while, so we are getting root. Okay, so while root, or we can set some variables, or temp equal to root. Okay, while temp does not equal to none, like this. We will shift temp equal to temp dot right. Correct.
Yes.
So in that way, we our temp will reach at the rightmost child. So temp equal to root, or what should be the condition? Temp dot I think right. This part is okay. What we are doing, we are setting temp on root.
Hmm.
Okay, and then we are checking while temp dot right does not equal to none.
Hmm.
So that means we are checking from the first root node. So root dot right it does not equal to none. We will move our temp to the temp equal to temp dot right. So in that way, this loop will run, and our temp will be set on the rightmost child. If there is no right child of the root, so this temp will set on the root.
Hmm.
Okay, and at the time we can also increment our counter. So this is the first case. We can set count equal to, let us see, okay, count equal to 1. Okay, so we are finding the rightmost child, and we are setting the count equal to 1. And also, if we can apply this condition, if count k here, then we can save result equal to uh, temp dot value. Okay, temp dot value and return from here. Okay,
So we will not be using the recursive function.
not return. Okay, sorry, not return. Uh, yeah, in this case we will not call this. Else part, we will call this above function return result. Else part we will call this recursive function now, but we will call this function on root dot left. Root dot, no, not root dot left, temp dot left. Okay, and after finally we will call the return result. So now this is the call. Are you getting the logic till now? What we are trying to do?
So, but like as we shift to right, we should increment count, right?
No, first we are just reaching to the largest element, first largest element. So in this part, actually, we are just traversing the tree to the rightmost child.
Okay.
Okay, after reaching the rightmost child, that is actually a first largest. So we are setting our count equal to 1.
Hmm.
Okay, and if suppose if we are asking only k equal to 1, what is the first largest? So we are checking this condition. If count equal to k, then we are setting result and return results from here. If our k is not equal to k, this count, that means we are asking the second or third, any other largest. So in that case, we are calling else part, and we are calling our recursive function on the left child node. So this is the temp value, which is the rightmost child, largest, first largest. From first largest, we are calling the recursive function. So this temp dot left comma k, in that way. Okay, and then we will use uh, this function most are not
So
able
this
to.
function is basically a traversal routine, right?
Yes,
It's not
traversal part.
there's nothing to do with kth element. It is basically R root and left, right? That's the order. So we can literally call it RML traversal.
Yes, yes, this type of traversal actually. So okay, so this type of condition, we are reaching left. This is the second, and suppose we are seeing the third largest. So in that case, not equal to none. Okay, I think still not. It will not work. So some logic is also required here. Let me give this input. Error we are getting. Okay, so root dot right is not equal to none. Number 3. We have to change the variable name. Sorry. Okay. Temp dot left, we are rolling. Okay. And
Sir, should we call that only when the left child is present, right? If it is not present,
actually, so we have to check the case like. So suppose we have like 10, sorry, 18, 28, like this, 5, 1. So in that way, first we are finding out the maximum. So this is the first one. If there is no max, you're correct. Then we have to traverse back.
yeah. So because here we are unconditionally checking the left. Before we call that recursive left, we have to check that it exists. So that means root dot left not equal to none, then we call that function. Otherwise, we backtrack to parent.
Yeah, correct. So actually, now we are focusing on this part if we have only this type of tree. So this is the first node and we are calling the left part. But this is not only the case. So we have to maintain all the case which can become in this problem. So I think some more logic is required to handle all the cases, corner cases. Okay, so just think about that. I'll also think after that. And so actually the current logic which we have written before, so that is actually work if we our root node have some right child node. So that is actually working on that case. But if root node doesn't have any right child node, in that case maybe it will fail. So I'll also find some another logic to cover all the corner cases for this, and you can also try to this. Okay, and next session we will discuss the complete logic, how we can write the complete code for this.
So tomorrow,
Tomorrow, actually, there is one PPA session. We this time we have shifted our week 7 PPA session on Saturday. So 6 to 8, the week 7 PPA session will be conducted by one instructor. Okay, and maybe next week we will discuss this problem on Wednesday or on Friday.
Monday or Tuesday.
Monday, actually, I have another session, another course. So Tuesday we can maybe Tuesday or Wednesday.
Sunday is a class. Bro.
No,
Sunday there
Sunday
is
is
a
the
class.
OPT exam. What is the Sunday is the
Oh,
last means?
no, Sunday is OPP exam?
Yeah, Sunday is the OPP exam for Python and Java in some course, SCT system command course.
Not for
Uh,
So
PDSA
not for the PTSA.
and not for DBMS as well, right?
Yeah, yes, I think DVMS are also not there.
both DBMS and PDSA on August 20 and 27. No?
Hmm. So actually, we are conducting some duties in the OPP exam, so cannot take the session on Sunday.
Okay, sir.
Okay, so this part I'll explore that what logic we can write for this. You can also explore during this 1 week. Okay, so this is now one problem for you also and me also. We will solve this. Now we can move to the another week 7 part. Decode. So as Wednesday we have discussed this Hoopman code, Hoopman tree. You know the concept of Hoopman codes and Hoopman tree. Where is the
Yes, sir. The prefix coding. Yeah.
Yes, sir.
prefix coding? Yeah. Okay. So this first question of Big 7 is also based on that. Here you have to write the code, write a function decode root and ciphertext. Okay. So root this is the reference of the Hoopman tree. Okay, and ciphertext is a one code in the form of 0 1. Okay, and in the string form. So the function returns the decode message in the form of string. Okay, so here actually you have given one tree in the input. This is a Hoopman tree, and you can simply read this information from the node. So this is the node structure. Actually every node contains the self frequency, okay, and symbol, and self dot left reference and self dot right reference. So this is the node structure of the each node in the Hoopman tree, and you are given a reference of root node in your function. Now you have to just decode the ciphertext using this Hoopman tree. Okay, so you can get this information using the self dot symbol. So symbol is actually a main character which we are storing. So you can see in the diagram. So leaf node is actually containing a main symbol. Okay, and internal node containing a some symbols, but that is not actually a main symbol. So that is actually combination of the child node symbols. Now input type is given like this. Sample input you can see 0001. This type of sample input is given. So how you can decode this input into a actual message using this Hoopman tree.
You have to traverse the tree from the root, and whenever you reach a leaf,
Hmm.
then that whenever you reach the leaf, that character will be there, and then you again
Yes.
start from the root.
Yes, correct. So in that way, you root reference is given, and you know that when you are traversing left child, so this is actually representing a 0 port. Okay, and when you are traversing a right child, this is a 1 value. So based on this information, you can simply read this character from the input strings 0 0 0, and you can traverse accordingly in the Hoopman tree. Okay, so at the time of traversing these code in the Hoopman tree, when you are reaching at the leaf node, okay, at any time when you are reaching at the leaf node, just return the character and reset your pointer to a root node again. Okay, so this process you need to repeat for the complete iteration of this input string. Then you will get a I can simply explain you. So for the sum part, okay, so 0, we will start from this first 0, so we will move to the left. Okay, so first 0 we will move to the left, next 0 we will move next left 5, okay, and next 0 we will move to 2. So this is B character. So first 3 0 is representing a B character. So we have reached at the leaf node. We will reset our pointer to a root node again. Then we will start again 1. Okay, so next bit is 1. So 1, that means we will move to the right. Okay, so now 14. Okay, and next one is moving 14 to 7, and next one is moving 7 to 4. Once again we are reaching the leaf node and we are getting A. So that means the next 3 1 is representing A. So in that way you can traverse the this segment tree and you can decode the message. Okay, so leaf node you can identify by if self dot left equal to none and self dot right equal to none. At any time self dot left or right both are none, so you can identify that this node is a leaf node and you can read the character. You can read the symbol from that node.
So the right leaf node 7 is repeating twice
Where?
here from 14 7 7.
So this is actually a frequency. Here we are adding 3 plus 4, we are getting 7, but another 7 is actually a actual frequency of one character. Okay, so here actually the leaf node is actually representing the main input symbol information. Otherwise, all are the internal nodes which we are getting the sum of the child
Some of
element.
the previous
Hmm.
pairs.
Okay, so now you can apply the logic for this simply traversing logic.
Say if so, we just see that if right and left both are none,
Hmm.
we are at a leaf node,
Yes.
and then we
Read the
just
symbol
we
value. Yeah.
remove the value,
Hmm.
whatever that value is.
Hmm. So just maintain one result string and appending every time. When you are reaching at the leaf, append the character into a result leaf.
Okay.
So the frequency is the frequency of that letter appearing in the document that you have analyzed or message, whatever.
Yes, yes. So last leaf node frequency actually.
Yeah. Then we have intermediate, which is sum of the frequency of its child nodes. Looks like that's what is going
Yes, yes. So here actually this is a Hoopman tree creation.
on.
Every time we select two smallest frequency and then we create the Hoopman tree from bottom side. Okay, so internal node is representing a sum. This. Okay, so you are given a Hoopman tree and based on the tree you need to decode the message.
So this is the simplest form of RSA 256.
Mhm. So So I have opened the Siddharth Replit. So your screen is live. If you want to explain with your writing the code, you want, you can. Yes, Siddharth, your code is complete, working. Okay, not working. Hmm?
എവിടെ
Yes, Siddharth. Hello.
Oh, sorry, 1 minute. Oh, ಕೈ ಹೊಡಿತಾರೆ ಇವ್ರು.
Siddharth, one thing in your code, actually input ciphertext in the it is in the form of strings.
Sir, it worked for me.
So this is the change actually when we are comparing. So just compare with the string 0 or 1. Yeah, it is working.
You don't have to check both the right. You just if one is none, the other is also definitely going to be none.
Yes, correct. So in the Hookman tree is actually a strict binary tree. So the child will contain the 0 child or 2 child. Okay, so if any child is 0, that we can see that this is a leaf node. You can write one condition only. Yeah, so this one code is written by the Siddharth on my screen. You can understand. So here actually what we are doing, we are simply setting our final solution in S as an empty string. We are just initialize with temp equal to root. Okay, and then we are simply reading each character from the cipher text. Okay, actually that is in the form of 0 and 1, but in the string format. Okay, so now we will simply compare our I character with the 0 string. Okay, if we are getting 0 string in the ciphertext, that means we will move to the left in our Hoffman tree. Otherwise, other condition is only that if our I equal to 1. So in that case, we will move to the right side. Okay, after checking this step, so if else part, we will check if temp, so current temp dot write. Okay, so that means we are checking the child information here. Temp dot write equal to none. So in the case of Hookman tree, if any child is none, that is representing a leaf node. We can see that. Okay, so if temp dot write equal to none, then we will read the symbol from the current node. So we are simply appending our symbol temp dot symbol, and we are appending this symbol into our final result. So S we are appending inside this, and then we are resetting our temp to the root again for the remaining ciphertext part. Okay, so in that case we will decode the our ciphertext to the original message.
So if the this will not work if suppose the ciphertext is not correct. I mean, if it is not
Valid.
then this will not work, right? So we are
Yes.
assuming that ciphertext is a correct text.
Yes, correct text. Or one last question is also depend on this. So in this case, after completion of this traversing of the ciphertext, if you are not reaching at the leaf node finally,
Right, right,
okay. So in that case, you can say that your code is invalid.
right,
Input ciphertext code is invalid. So that is actually a third problem in this type coding. Okay, but not using this Hookman tree where we are using the Hookman codes. Okay, here also
Here we
if
are using what?
Hookman codes are given for the each characters. Okay, not the Hookman tree. So in the case of Hookman tree, so after completion of this loop, if your this temp variable is not reaching at the leaf node, it is in between anywhere.
Here it will be same, right? Like temp dot right is none, temp dot left will also be none.
Yeah, in the case of Hookman tree, if one is done, definitely another will also be done. Okay. So after completion of this loop, we can directly return our solution. So this is the small logic for this. I think it is clear to everyone. Okay, so second problem, which is based on the greedy algorithms, and that is actually popular algorithm, fractional knapsack. The called name is fractional knapsack, and the another version of this problem is 0 1 knapsack. So that actually solved by the dynamic approach, but fractional knapsack can be solved using this greedy approach. So what is the problem?
So what did you say? Fractional what?
Fraction. This is popular problem actually. The fractional knapsack. The problem name is actually fractional knapsack, and another version is 0 1 knapsack. So what is this fractional knapsack meaning here? So here you can read the problem statement. Write a function max value selection item comma c. Okay, so here item information is given and c is representing a maximum capacity you can select. Okay, so this is represent c is representing a capacity that accept a dictionary items where each key of the dictionary representing the item name. Okay, so key is representing item name and corresponding value is a tuple. So inside each tuple we have two value, number of units and value of all units. Okay, so in the first example you can see we have the one item 1 which have 10 unit and the value of all 10 unit is 60. Okay, like in that way, and function accept one more variable c which represent the maximum capacity of unit you can select from all item to get maximum value.
So that means, let's say I'm a thief, but
Yeah.
I have some kind of a stack, like I have a fixed capacity. That's the only thing. Let's assume. So
Yes, correct.
if I go to a valuable place, the volume is a constraint. So first tuple element is giving me how the volume is contained, and the second one is actually the value. So you want to keep gold and diamond first, right?
Yes, correct.
But if it is very large, then I can't put it in my sack, right? So I think it's a constant optimization problem. You are trying to maximize the sum of the value
Yeah,
given the
profit
sum
like
of the capacity.
one capacity is there and you want to that to get maximum profit by the value, and so how you can select the items,
So the constraint is at the aggregate
units
level,
actually.
not at a individual unit level.
Yes,
The constraint is
aggregate.
the aggregate level. So that's what makes it even more. So you can't like select or deselect an item. Actually,
Yes.
you are doing it on a basket of goods, not just one.
Like if you are going outside and you want to buy tomatoes, right? And then you cannot.
Well,
Yeah,
that's
you
actually
cannot
opposite. The
carry like
value is
20
negative.
kg tomatoes just because discount will.
Yeah, now I think it has become gold. Yes.
Yeah. So actually, the name of the problem is also created using this theory, this story, thief story. Okay, and the another problem is also a 0 1 knapsack. Okay, so in that problem, 0 and 1 means we can pick the complete item or we have to leave the complete item.
So that's like
Okay.
integer programming, right? So it has to be rounded unit. This one is more like a real number. You can take a fraction.
Yes.
Right?
So, but in the another problem here, actually we have some unit for the each item. But in the another problem, each item have a 1 unit.
Right, right.
Okay, so you cannot pick the partial part of that. You can either pick the complete unit, otherwise you have to leave the complete unit. So that problem cannot be solved using this greedy approach. Okay, but here actually we can solve using greedy approach. So we can select the fractional part of the one item actually here.
Sir, it's like I don't know, like if there is a Mr. Beast video, it's like he goes with some people in a store, electronic store, and he gives them 10 minutes to uh, select the items which they can fit in a basket, and he will
Hmm.
pay for them. It's like this only. You have to select all those maximum
Yes,
items,
maximum value
but
items.
you cannot fit more than a certain quantity.
Hmm. Yeah, correct.
Put a bunch of iPhones.
Hmm?
Yes, go find Apple items, especially iPhones.
Hmm. Okay, so tell me how you will start this.
So first, I think you will have to find the value of each unit, maximum value of unit of all the keys.
Okay.
Suppose in this case, one has a unit of 6. One has
Correct.
a unit value of 6.
Yes, correct. So this is the thing. We have three item here. So one item, two, three, and we have 10 unit for the one item, 20 for the second, and 30 for the third. Okay, so total value is given here. Okay, for the 60 is given for the all 10 units. 100 is given for the all 20 units, and 120 is given for all 30 units. Now, because here we can pick partial, okay, so we can pick 1 unit, 2 unit from any items like this. So we have also calculated the value for per unit. So here per unit value is 6. So
6 and
60
this is
divided by 10, 6. Okay, another per unit value for second item is 5,
5.
and per unit value for third item is 4.
4. But sir, we have to pick all the units, right? We have to pick all the units, right?
If yeah, so suppose what capacity is given, so capacity is given 50.
50.
So if your so first you will start picking from the item which have the maximum value per
Yes,
unit.
yes,
Okay,
yes.
1 unit. So you will pick this item first because this have the maximum value per unit. So then you will see that how many units are there. So this have 10 units and your capacity is 50. That means you can pick all the units because the total number of units are less than capacity. Okay, so once you pick this 10 units, now what is the remaining capacity?
Subtract the
Yes,
40,
50.
now 40.
total.
40.
Okay, 40. So once again you will select the second maximum value item.
So I think we
Okay,
have to select 10 again then. We
no,
have to
why? No, no, no. So this is the total 10 unit. How you can select again?
because the answer is given as 240, I think.
So that is actually a value,
Yes, yes, yes.
total value. Okay, so if you have here, we have only 10 units.
Okay, okay. So
So
you cannot select
if you have selected this 10 unit, then you
you cannot
cannot select.
select it again.
Sir,
Yes.
but if the item number 2 and 3 have value of 100 and 120 respectively, why would we select the item 1 to begin with?
So this is the total
Value per
cost.
atom.
Okay, so this is the value of all items, and now we will calculate the value of per unit.
Okay, 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 okay.
Okay, and based on the per unit value, we will sorting in the decreasing order, and then we will start from the first. So this is the maximum value item. Okay, per unit item. So because of that we are selecting, so 10 we are selecting, we are getting total 60 cost, 60 value. Okay, now remaining capacity is 40. So 40, then we will choose the second item because this have the another second largest value item. So 20 is smaller than 40, then we can select all the items for this item. Okay, all the units, sorry. So 20 we are selecting and we are getting 100 cost for this. Okay, now what is the remaining capacity? 40 minus 20 is 20. Now we have the third item remaining, and third item have the 30 unit, but remaining capacity is only 20.
20.
So we can select only 20 part for this. So if we are selecting 20 from the third unit and cost per unit is 4, so 20 into 4 is
80.
80. Okay, so we are selecting 20 unit from third item, and we are getting 80 cost for this. So this is the first item, and this is second item, this is third item. And total sum we are getting 100 plus 80 plus 60, 240. Okay, so this is the problem. We say that fractional knapsack. So can you just try to write the code for this?
So I think the tricky part was calculating the unit price. So you have to take the second tuple element divided by the first tuple element. The,
You have to create the another dictionary to maintain
correct.
this,
And
right?
then you have to sort the dictionary based on the descending value of this ratio.
Yes.
I think that was the tricky part. We have seen all these.
Or you can create a list.
Uh,
Okay, just read the each item from the dictionary and create the list, and in the list maintain one tuple where the first value is the cost per unit cost.
got it.
Then just apply. Oh, okay, so in that way you have to apply the reverse order.
Yeah. So I think dictionary, if we do sorted with lambda function x1 by x0 and then reverse equal to true, it should do it.
So it will also work.
Yeah, that is actually a more easier way. Then we can then we have to do that key value pair. We have to loop through the dictionary capacity, fill in the highest, then loop through until we fill in our capacity, then we stop.
Yes.
Yeah, so we have to
Just
calculate
pick the
capacity.
item.
Yeah,
Yeah, pick the
so,
item based on the capacity and
correct.
update the capacity. So repeat the process.
Yeah. Now I think logic is fine, sir.
So I'm just giving the 0 1 knapsack problem example. Suppose we have one item where weight is given and value is given. Like, yeah, so you can see this example for 0 1 fractional, so 0 1 knapsack problem. So here actually weight is given for the item. Okay, here this is not representing a unit. This is representing a total weight, and capacity is representing total weight you can pick maximum. Okay, so this 15 is like a total weight you can pick, and the value of each item is given. So in that case, you cannot pick the partial part of the item. Okay, so 0 1 is representing this. And also you cannot apply the greedy approach, because if you sort this item based on the value, so you can see you will get this 100 first. Okay, so this type of problem you have to check what combination is required to get maximum benefit. So each combination need to check, and based on that you can select the answer. So that is actually solved by the dynamic programming approach. So week 9 we will see this problem also. Okay, how we can solve 0 1 knapsack using dynamic programming.
Test is passed, sir.
Okay, 1 second. Name? Your name?
Devasmith.
Okay, they asked me. 1 second. Okay. So first thing, you're sorting the items directly in the dictionary by the per unit value. Okay.
Yeah, that's a price.
And reverse equal to true.
Yeah.
Correct. In the decreasing order. And simply total value you are getting 0 and remaining capacity is total C. Fine. So now you are reading the items from the dictionary, sorted items, and item and unit comma value in this
Yeah,
pair.
that's a tuple. That's why.
Tuple. Okay. So if units are less than equal to remaining capacity, okay, when total value you are adding,
You
so
get
value is representing the total value of all units, na?
yes.
Okay, you are
In
picking all the.
all
Hmm.
picking all the unit.
Yeah, correct. You can pick, and after that you are decreasing remaining capacity minus total unit
Yeah.
of that item. Otherwise, if this condition is not true,
So then you have to
then
pick
you
fraction.
fraction part. Okay, so remaining capacity divided by unit. Oh, okay, so here you are calculating the value for per unit. Huh?
Yeah. So if
Okay.
I got let's say only 10 cup left, but
Hmm.
then I divide it whatever the capacity by unit for that item and then calculate the fraction. Then for the
Yes.
value, I multiply the fraction of the value to get the total value and add it to the.
Yes, yes, correct. So here you are calculating the total cost for that fraction,
Yeah.
and you are adding inside the total value and break. Yeah, so this is the last option actually. You will get the last case. Okay. Okay, so that is fine. So suppose, so fraction remaining capacity and unit is less than equal to remaining capacity. Okay, unit is okay, fine. Yeah, it will work on the all case. Yeah, correct. Logic is and code is correct. Yeah, if if anyone are facing any problems, you can see the this code logic. The logic is very simple, but you can see the code how you can write the code. The first part is the sorting the dictionary. You can just write the code, different code for this. You can just read the value from the dictionary and you can make the list if you're not familiar with this sorted function on the dictionary. You can simply create the list and where you can maintain the tuples where the first value you can represent by the cost per unit, and then you can simply apply the list dot sorted like this function sorted. Okay, in reverse order, and then you can read the item from the list. Otherwise, if you are familiar with this sorted directly dictionary, then you can directly sort the dictionary, and after that simply traverse the items. If units are less than equal to remaining capacity, definitely you can pick all the items all the units for that item. Okay, and you can just add this total value in your final cost and just reduce the remaining capacity, just reduce the units for that item from the remaining capacity. Otherwise, this is the
Sir, I did this unit value because to make it easy. Otherwise, typically we are k comma v when we are looping through. Then you have to do v0 and v1. It makes it a little messy. So I just
yes, yes. So this naming of the variable is good. Here, if someone is read the code, definitely can understand easily by this naming. Yeah. So else part is only when your remaining capacity is less than the total number of units for the item. So in that case, just pick the remaining capacity items and just calculate the value for that and add in your final answer and break the process because this is the last step. Okay.
So
So
even if I don't break, it will create like fraction 0 and it will end basically. It just
yes, yes, but it will iterate all the items.
yeah, it will
It is
just
not required.
yeah.
Okay, nice. So yeah, you can move to the third problems, and third problem is also based on the this Huffman codes. But the Huffman codes are given in the different format, not the Huffman tree. This time Huffman codes are given in the dictionary.
Sir, you can give us the OPP question and the Huffman tree. If we can crack it, then we should deserve marks and play that game.
Huffman tree questions. So actually, in the previous terms, we never asked the question based on the Huffman tree, the OPP exam.
So there are two methods you said, like tree will be given and then you have a coded string, you have to decode it. That's one method. Other is
Yes.
you have given the prefix code, you read the sequence from left to right and you decode, right? These are the two methods. If we practice these two, then it should be okay.
Yes, 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 correct, correct.
Yeah.
So next question, if you see the next question, problem number 3. Check validation of message. So here you need to check the given code is valid or not. So you can see here the code is given for each character. Okay, so this A is the character and a Huffman code is given for this. So no, we are not asking this is a valid Huffman codes or not based on this prefix and thing. Here we are asking that this encoded message is actually created by these Huffman codes or not. Okay, so that which you are saying that another problem. So this Huffman code is valid using this prefix information that can also be created. That one problem can also be created on this. Okay. But this is another different problem. Okay, Huffman codes are given, one cipher text is given. Let's check that this cipher text is actually valid text or not.
So it is similar to problem one. So problem one use the tree. Here it is, you are using the prefix coding basically.
Yes, yes, code Huffman codes.
Yeah.
But you have to.
So one thing we
us the
noticed,
dictionary.
just based on our knowledge, it cannot start with a 1. It has to start with a 0.
Why?
What is 1 here? If I only give a message 1, there is no code like
No,
1.
no. So we are getting this 1 1 no? For F.
But in this case, 1 0 1.
If we go on right, so it will be 1 only, right?
So here there's a maximum length of my key is 4 bytes, 4 bits, right? So my lowest frequency occurring word has been given the most amount of bits, right? So the letters C and D are least occurring, so that's why they are the bigger strings, right? Or
Yes.
codings, right? So either 0010 or 0011. So when I look at the first 4 bits, right? 1010.
Okay, but it is creating 2 characters of E. You cannot. Okay, so based on that, you cannot identify that.
Yeah. So basically, we read it letter by letter, character by character, and The moment it matches with any key, that's the value, and then we reset and then start the sequence again. So it's a variable length basically, right?
Yes.
It could be one, two, or basically two, or yeah, there's no single.
So during the traversing, each time you have to just check that this code is available in your Hoffman course or not.
Right.
Okay, if not available, just append the next character.
If key not in dictionary, so that's
Okay, so
basically.
if one is not in your dictionary, just append one more character in this length, 10. Now check 10 in this your dictionary. If 10 is available, yes, E. So just replace this by E and start from the next digit. One once again, one, in that way. But you have to reverse this dictionary first. You simply can make this value as a key and character as a value. So it will help for you. Okay, otherwise you have to traverse all the value to match every time.
So we
Sir,
have to
So
convert the order n to order one doing
sir,
that.
what did you say? Like if we do not want to like, because like if we have to check that this value is matching, we have to go through the dictionary, right, to see if
hmm.
it is matching or not. Every time
Yeah,
we.
so in the initial dictionary, the format is character is given as a key and value is given as a code. Okay, but when we are reading the code from the input message, so we are reading the code actually. So you have to match this code from the value of the dictionary.
Okay.
Okay, so for matching the value of the dictionary, you have to traverse all the dictionary, all the keys. So that is actually difficult. You have to traverse each character, then you can match. But what you can do, you can simply reverse this dictionary. You create the new dictionary and just make value as a key and character as a value.
Okay. Okay. Okay.
Okay, then you can directly see after reading one, just you can see that this one is in dictionary or not in the constant operation. Okay, if one is not exist in the dictionary, append one more character in this string. So 10 now. Just check 10 exists in the dictionary or not. If exists, then return the value for return the character for that as a output message, and again start from the next digit. So next 10 in that one. So initial 10 will create 3E, but next time you are getting one, it is not in the dictionary. You will append the next 1. So you can see this is for F. Okay, so in this process, once you are reading all the these characters, if any character is left without which is so if any character is left in the input strings which doesn't exist in the dictionary, so that means this code is invalid.
Sir, what if we just like we find if the character is there,
Hmm.
and then we uh, if we for example if we 10 is there, right?
Yes.
So we remove 10 from this.
10 if so you have to take one pointer here. Okay, so you have to set like string, so s equal to, you have to set 1. Okay,
Okay.
s equal to 1, then you have to check in your dictionary s equal to 1, s is exist in your dictionary or not. If not exist, then append the next character in this string. Now 10. Okay, now 10 is exist, yes, exist. Now just reset your string s equal to empty string once again.
Okay.
Okay, and then once again assign the next character 1, s equal to 1, then repeat the process. Okay, so repeat the process, append the character uh, till now until you are not getting the items in the dictionary, that okay, key in the dictionary.
Okay. Okay.
Okay, so in this process, if any character is remaining in the last, so that means that total code is not valid.
Okay.
If complete if you are getting the decoded message for complete strings, okay, and no character is remaining after that, so that means that is a valid code which is created by this subman course. Okay, so this is also a similar iterative process like a first problem. But this time you are reading the data from the dictionary, not traversing from the movement tree. So the answer will be decided based on the remaining character. After completion of the iteration, if any character is remaining without any decoded message, so based on that you can return the invalid answer.
Yes, sir, I have written, but some all the answers are not passing.
uh, who's talking? Siddharth.
Yes, yes.
One sec. Problem number 3 na.
Yes, yes.
Siddharth. Okay, so first thing is okay. So first thing is in our dictionary, the character is given as a key and value is given as a code.
Okay, okay, okay.
Okay, so first step is this required. You have to reverse the dictionary.
Okay, okay. Yes, sir, passed.
First, okay. Hmm. So now you have created the another dictionary reverse and s equal to empty string for I in message. You are appending the message character in s and checking s in d. If s in d, you are resetting your string, correct? Yeah, correct. Okay. So in final, if s is empty, that you are returning true, otherwise false. Yeah, correct. This logic is okay.
Partial, I mean, I've coded it, but two cases passing, two cases return.
Who is this?
Harassment.
Okay, Devasman, 1 second. Okay, reverse dictionary you have written K comma B as for items. Okay, reverse dictionary V comma K. This is fine. Decode message string current code. Okay. Now bit in message. Okay.
Yeah.
Current code.
Bit by bit doing it, and
Hmm. So you are adding current bit message.
so
Okay,
every
fine.
bit I'm reading and appending to the current code, and then every time I'll check for the current code in the reversed dictionary, and if it is there, then we know there's a match. Then we pick up the value,
No, no. So what you are returning here, last line?
true or false. But I mean, if it is true or false, the decoded message.
No, message is not given, na?
So only the decoded message.
Yes, decoded message is given.
Only this much should be.
So just check that this current code is empty or not in the last.
Failed now. Sir, after finding the, then I had to initialize it. Then the thing will continue. And so when the message string gets exhausted, then the loop will automatically.
Yeah, this is the first part is okay, but in the return part,
Yeah.
okay, so we are actually checking that this message which is given in the decoded form is valid or not. It is created using the Huffman code or not. So to return the answer, you have to check if current bit. Okay, so current after traversing all the bits from the message, so is there any remaining bits are available in the current code which is not exist in the Huffman?
Got it, sir. Got it.
Okay, so just check in the return statement if current code is equal to empty or not.
That is it.
Not list, string.
String now. Yeah. Yes, sir. Yeah. Pass now.
Okay.
Yeah, that part I was not sure because it could be a partial message, right?
Hmm.
Can I assume that the message would be like complete and yeah, be
Yes.
partial key or whatever.
Hmm. Okay. So all the problems are discussed. So only one problem, B6 problem number 3. I will check the solution. You can also check. Okay. And I think second problem is okay. You have to check the algorithm for this Kruskal algorithm. Then you can solve the problem number 2. So here actually we are simply creating a MST, minimum spanning tree, but the edge which are not coming in the MST, we are returning as a answer. So just apply the Kruskal algorithm and you can simply write the code for this. So any query or problem?
So we have to define the union find class here. You know, initialize the rank and then do the find and union function.
So you have to just go through the big six Kurosawa
Yeah,
algorithm.
yeah, I had my notes, so I kind of referred that, but
Hmm.
that's what I used. I then after that it's very easy because then you just do the curly.
Yes, yes, yes.
Yeah.
Otherwise, you can simply for validating the solution, you can simply write the simple Kurosawa algorithm.
Okay. Yeah. So
Okay.
since it was already I had typed earlier, so I just copy pasted.
Mhm.
But I think in OPP I can't do that.
Yes.
I can't copy paste, and it's difficult to that. The particularly that union function is problematic. Find is okay.
Or you can also use this Prim's algorithm.
Okay.
Okay, the Prim's algorithm. Okay. Still, you have to add the additional part of the Prim's algorithm to check which edge is coming or not. But Kruskal, I think it is easy compared to the Prim's.
Yeah, so Kruskal is easy, and once I define the class, then it is
Hmm.
fairly easy. I solved it, but it just worried that in a OPP it will be difficult to solve because you have to
Yeah.
define the class. Otherwise, if you don't define the class, you have to write the.
Hmm. So initialization part, you have to done this component value for each node,
Yes.
size like this. All you have to initialize. Then you can write. Okay. So any other thing? So tomorrow actually we will conduct the B7 PPA session from 6 to 8. Okay. And so one extra session you're saying that maybe in next week we will schedule.
Yes, sir. Monday or Tuesday, whatever works for you.
Not for Monday, and maybe for Tuesday or
Yeah,
Thursday. Like.
that's fine, sir. So
Mhm.
anyway, it's like extra, so it's all right.
Yes, yes.
But these things require a little bit of time. It's not easy. So in fact, we had covered in MAD one. That's why the prefix up and coding is slightly. Otherwise, first you have to understand the concept. Once you, that's half the problem.
Hmm.
That is actually coding it.
Yeah. So actually, sir, there is some sequence. PDSA, this type of course should be complete before the MAD one or this type of course.
Yeah, because MAD one, I think week 2 or week 3, we actually solve this problem, right? Somebody will give you
Mhm.
the code, you decode. So we have actually done it by hand. So,
Yes.
so then it becomes at least a coding problem. But once you understand and code, like for example, union find, like that's a completely new data structure we have never seen in our life.
Hmm.
Find it, disjointed set, how to define the rank. I mean, we understand the concept. But then when we read Corman, that inverse Ackermann function, then everything goes for a toss.
Yeah. So these are actually very core subject. DVMS also. So DVMS should also be complete. That is also a prerequisite for I think MAD one or core requisite. But PDS should also be complete in the programming domain
So
first.
it should be core because there are certain things in DBMS which I believe if you do PDS, it would be helpful, like B tree, 2, 3, 4,
Yes, yes,
you
yes.
know.
And
Uh,
also, I remember that in the MAD one topic is related to the this indexing part in the database. One week is
DBMS
there.
actually, DBMS indexing part, multi-level index also was covered.
Yes, yes, and
Yeah.
yeah,
The index cannot be loaded to the memory, so you have to create a multi-level index. That was actually pretty intense.
okay.
So after all, you don't remember which subject you read, what everything it becomes like that. Union
So
find problem.
yeah, we are planning to some activities after completion of the course actually. Okay, for the practice purpose. For suppose you are completing this PDSA, then what you should do to revise the things of PDSA, because in general, company asks the very conceptual thing or coding question in the recruitment process. So, what should be the activity to revise the things at the time of placement? But it is currently in preparation in stage.
Many times they ask for dynamic programming also, like minimum sub.
Yeah, so DP is also much important topic for this after this PDSA in the competition area. So you can also start. You can just select the any competitive platforms. You can choose the like lead code.
Leet code has 434 problems, sir. It will take for a year, probably 2 years, 3 years to complete it.
432 only?
I I had made a list of 434.
No, I think it will have lots more than 432.
Maybe I selected some topics.
Yeah. So you can start from the easy problems, okay, and on the lead code and topic wise, which you have already done in the PDSA, and just try to solve what type of problems can come in the real life problem as a competition problem. So this type of activity we are also thinking after the course. Okay, any very specific query from the today live coding problems? Yeah, Ritik?
OPP difficulty will be similar to this, easier or more difficult compared to these live
Easy to
coding.
medium side, you can easy to medium. We generally not give difficult questions.
So even after you help and tell us the reverse dictionary, it would have never occurred to us, right? And then you gave a hint that find the price per unit, right? Otherwise, you would have just
So at the time OPP, you have already solved the similar type of problems before.
then
Definitely,
it
you will get after reading the problem statement, you will get the idea you have already done this before. So maybe you can use the same similar logic.
give graded question difficult, no problem. We'll spend more time. It's only the time that
Yeah,
puts it
time is the main problem. Actually, in
more
two
pressure.
hours, strict.
Yeah. Even if you give us check last for union, fine, that itself is enough, right? There's no
Yeah,
trick
correct.
involved, right? It's just,
So we actually generally ask two easy problems. Okay, and some easy logic is required, and two mediums like this. We generally not give any too much difficult problem, so not too much thinking time is required like this.
okay, thank you. So let's maintain that tradition.
Okay. Okay, then if there is no query, then we can wind up the session. Thank you, everyone.
Good night, sir.
Good night.
Thank you, sir.
I always get confused with those lambda functions. Maybe I need to write.
So
Yes, sir.
I
Thank
also
you.
I also never use this sort built-in function like this Python.
So for reversing the list is yeah, for
Actually, here you are using this Python language. Otherwise, suppose if you